Right? So basically with the forward value expression here in compounding, we can move a value into the future, and what we basically did in the present value, we have a cash flow in the future, and we moved its value to today. So basically the interest rate or discount rate here helps us to shift payments and values through time. And that's the general logic of kind of the present value method. Please note the relationship here between present values and the returns or discount rates. So what happens if you have a higher return or higher discount rate? So if this number goes up, then you divide with the number, that means that your present value goes down. It's a very important relationship between kind of values and returns. So if this number here goes up, then your present value will go down. So for example, where this is at the moment very important would be the bond markets, right? So where interest rates are increasing at the moment, right? The ECB just increased their interest rates, so the government bond rates are going up. What does that mean for the prices of government bonds? Well, the prices are going down at the moment. So in the moment when interest rates rise, it's a very bad time to have bonds, right? You should buy the bonds when the interest rates are high, because then they're likely to fall. When interest rates are going to fall, you will have capital gains where prices will go up. Right? So that's, in the bond market, a little bit mind-boggling always, because returns and prices go in the opposite directions. Right? But the same is true for kind of stock investments as well. If you have a very high expected return, it means R is very high, you should not be willing to pay a lot for it because the price that you have in this computation is rather low. Right? So low prices means high returns or high discount rates. So, as I've written it down here, I've not written a tilde on top of these variables. That means that these are the computations or the rules when we have absolute certain knowledge about what those cash flows are going to be. If you have certainty, so if this year is absolutely risk-free of risk, then the discount rate that you should use is the so-called risk-free rate. Right? So there's always a rate that is applicable for something that is free of risk. Typically, we would use the government bond yield here as a proxy for it, because it comes the closest to what probably risk-free could be. There is nothing, I think, that is absolutely zero risk, so there's still a probability that Germany can go bankrupt, but the German rates are probably the safest, right, if you want to put it that way. So it's not absolutely risk-free, but it's the lowest risk rate that you could probably have. And there are some countries which went bankrupt. Argentina is, I think, a big example, sometime in the 80s or 90s. So it's not. Yeah, I'm not aware of that, but it might well be possible. So, yeah, but the biggest problem that we had was here in the Eurozone was Greece, kind of in 2014. So that was, there was at least a danger of that. But, so it does happen, so government bonds are not always free of risk, but it's that what comes closest to it. So if the cash flows are 100% certain, the discount rate that we use is the so-called risk-free rate. Now, of course, this is, well, probably besides government bonds now, not really kind of helpful. So how can we make it more realistic? Because cash flows are kind of uncertain in the future. And for that, I kind of write this down a little bit more kind of rigorously now. So first of all, we have to think about what that means if something is uncertain. So now let's add the component risk to it. Maybe just as a note on the distinction between the two words that I just used. So uncertainty as one word and risk as the second one. Actually, the situation which I describe here is the situation that we call risk. Uncertainty is a general word. Uncertainty means you don't know what's going to happen in the future. Risk is a little bit more specific. Risk means that you actually can make computations, and for those computations you have to know a couple of things. And these are the things that we need to know. We need to know what are the possible scenarios of things that could happen in the future. That's kind of showing the tree here. right? So every branch of this tree here is a scenario. We have in this case capital N scenarios or states. That's the same thing. So we need to know what the so first of all, we need to know how many scenarios are there. Then the cash flow that we would get from a financial product in each of those scenarios. And finally, we need to know the probability for each scenario. And under this situation, when we have all this information, when we know the probabilities, then we can do computations, and that's what generally referred to as risk, as opposed to uncertainty. There might be a situation in the real world where you don't know what the probabilities are. That's the typical situation, sometimes referred to as ambiguity. But the problem is that we can't do any computations, right? So still you can go about this and estimate what these probabilities are, you can guess them, right? And then kind of work with that. So ambiguity is a really difficult topic, making things a little bit more complicated. So typically we assume that we can at least estimate those probabilities, and then we can apply the framework that we have here. So how does this match now with what I've showed you previously? So on the previous page I've talked about no risk or risk-free investments. So how would a risk-free investment look like in this setting? A risk-free investment would basically mean that you get the same cash flow in all scenarios. That would be something that's free of risk. Right? So the blue part here, that would be risk-free. And maybe let's do another example of a risky investment that could look something like this. So that would be risky. Risk-free investments have the same cash flows in all states, right? So which basically gives us 100% probability for that cash flow. And if there's some variation among these numbers, we call it risky. I mean, I've drawn a picture here where we have many different scenarios, but we can actually simplify this quite a lot. So for example, for a corporation, there might actually, suppose you're a debt holder of a corporation, there might only be two scenarios which are relevant for you. The situation where the company is doing well and your debt is going to be repaid, or the situation where the company goes bankrupt. Right? So basically you only need to have one probability, that's the probability of bankruptcy. Right? So in the corporate bond markets, that's the only probability that you're interested in. And you only look at two scenarios. Right? And then you would think about, okay, how much money is promised when the company is doing well? It's one of the notional amount of the bond. And then you're estimating, okay, how much do I get when the company actually defaults? You think if you can recover part of your investment. So rating agencies focus exactly on that one scenario where you go bankrupt, and they try to estimate what's the probability of bankruptcy and how much money do I get when I'm bankrupt. So they're only looking for basically this two scenarios. That's what they look at. And for option pricing, we're also just looking at kind of these trees which have two scenarios, because that will be kind of sufficient to do the pricing.
Is this why we have 1 and 0? So we have two scenarios.
Yeah, so I mean here I've drawn it with n scenarios, but yeah. So the if you cut off the bottom part, the minimum kind of the minimum states or scenarios that we need to have to model uncertainty would be 2 with 1 and 0. That's kind of the simple context that we're often looking at. So now, how do we work with this scenario now, or the setting where we have uncertainty? How do we have to adjust our present value method? So how do I have to adjust this formula here basically now under uncertainty? Right? Under certainty, I know exactly what this cash flow is, so it's not difficult, and I have the risk-free rate. What do I have to do differently? And the first thing is that instead of the cash flow that you use for discounting, you're using the so-called expected cash flows. And this is now a little bit of a review of probability theory. So expected value is nothing else than the probability weighted average of your cash flows. Okay. So if we maybe do the example here, the red one, right? So that will be my probability for the first scenario times the cash flow in the first scenario, plus my probability of the second scenario times the cash flow in the second scenario, and so on. So my expected value would just be the probability for the first scenario. Right? So you always take probability multiplied with cash flow plus probability multiplied with cash flow. So that's the expected value. So I use this ladder here with the double lines here to denote the expected value operator that you should hopefully have seen in the statistics class or probability theory class before. Right, so it turns out that we can just, instead of the cash flow, use the expected cash flow for discounting. And that would give us the correct value. So that's the first amendment. Right, if we go back to our formula, right, so we have thought about, okay, what can we do with the numerator? Just use the expected cash flow. Now let's think about what we have to do with the discount rate. Now it gets a little bit more complicated. Again, we're going to study a formal model of how to link the discount rate to the risk. But let me kind of give you the brief intuition behind it. And for that, I would like to ask you a question, and I will kind of pull up a poll that you can kind of vote on this. So I'll ask you now to decide between these two alternatives here. Suppose you don't have to pay anything to enter this choice here, or the payment has already been made, it's sunk cost, and it doesn't matter anymore. You have the choice to either get a payment of 100 euros, certain, without risk, or alternatively, you can participate in this lottery here, and the lottery gives you, with a probability of 50%, a payment of 200, and with a probability of 50%, you don't get anything. Okay? And suppose you can enter this for free, right? So you never lose money, but you can basically choose between this coin flip and the certain payment. And now the question would be, for which of those two alternatives do you decide? Which one do you pick? And I just quickly have to switch to my laptop.